Assalamu alaikum, my dear student. How are you? I hope you will fine. Now, student, today our topic is double integral over rectangular region. So, so that I will define you what is double integral. The definite integral can be extended to functions of more than one variable that define as the function depend on two variable f of xy. So the double integral of functions, the double integral of function f of xy is denoted by double integral r f of xy into dA, where r is the region of integration, where r is the region of integration in xy plane. Now, student, if we consider the diagram, with the help of diagram, you will see that it is a plane and it is a rectangular cylinder. This is called is the region of integration in xy plane because it is z is equals to, when the function depend on two variable, it means z is equals to f of xy. It is a region of the integration and the function depend on two variable. And if you find with the help of double integral, how can you find it the volume of double integral? So the volume of double integral is d is equals to double integral r f of xy into dA, where dA is equals to dy into dx. Similarly, or if you determine the change of order of integration, there is no change. In both way, we will consider and find the volume. Now, what is area of double integral? Represent by capital A, double integral r into dA. Means we don't need, if you find the area of double integral, you don't need the function. Without function, if you integrate, where dA is equals to dy into dx or dx into dy. If you consider, if you find the integral with respect to y then x, or if you find the integral with respect to x then y, it means the area it should be same. Similarly for the volume, and if you find the volume in double integral of the given function, if you integrate with respect to y then x, or if you integrate with respect to x then y, the volume it should be similar in both cases. Now after that, what are the properties of double integral? D dot I represent here double integral. Now the first property of double integral is double integral R. R is the rectangular region. If you have both two functions f of xy and g of xy, of dA, if you integrate, which is equals to, if you separate them, then you integrate. It is our first property of double integral. First you separate and then you find the integral. Now the second property, if the double integral R, R is the rectangular region in two dimension, it means if you two functions, if they are subtract, then you separate them and find the integral. F of xy into dA minus double integral R g of xy into dA. It is now the second property of double integral. Now the third property of double integral, it is, there are three basic property of double integral. If k is any constant function, if it is multiplying by the function, when the function it is depend on two variable into dA, which is equals to k is any constant outside the integral, and then you find the double integral of the given function, they are equal. So there are three basic properties, student, of the double integral. Now after that, student, we will continue the lecture and define what is partial definite integral. It is very important for you. Student, if you find the double integral, if you find the partial definite integral in a single form, if the integral a to b f of xy into dx, or if you find the integral c to d of the given function with respect to y. This is called partial definite integral. Now, we are applying the definition of partial definite integral and write an application, evaluate. If you have given the integral is x cube y into dx and the limit of x is 0 to 1. So if you find the partial definite integral, it means if you integrate of the given function x but y keeping constant, so it means y, if you write outside the integral 0 to 1 x cube into dx, then you integrate with respect to x, x4 upon 4, when you applying the limit, the answer it is y upon 4. Now another application, if you find or evaluate the partial definite integral with respect to y. For example, if you have given the value of y, limit of y is minus 1 to 1, function it is xy square into dy. In this way, if the function depend on two variable, but we will consider only integrate with respect to y, it means x keeping fixed. So if it is x keeping fixed, it means we write the variable before the integral. So it means x of integral from minus 1 to 1, and when we integrate only y square into dy, because x keeping fixed, we write outside the integral and integrate y cube over 3. Then we are applying the limit. So it means when we are applying the limit minus 1 to 1, that means the answer it is, if you integrate x over 3, and 1 cube is 1, minus 1 into minus 1, it is plus 1. So it means it is 2 upon 3 of x. This will be your answer of the given integral. So there are two applications of partial definite integral. If the function depend on two variable, it means if you integrate with respect to x, so then y keeping fixed, we write y on the before the integral sign, and you integrate with respect to x only. So this type of integral is called partial definite integral. Similarly, if the function, if you have given it is in two variable, and if you integrate only with respect to y, so it means x keeping fixed, we write the variable x outside the integral, and integral from minus 1 to 1 y square dy. So the integral value is y cube over 3. So this type of integral is called partial definite integral. Now we will move the next point, what we call it iterated or repeated integral. Some books written as iterated, or in another way we call it repeated integral. Basically, student, for example, what are the repeated integral is a partial definite integral with respect to x. If you find and y keeping fixed, and similarly, if you find the partial definite integral with respect to y and x keeping fixed, then integrate So this two-stage of integration, process is known as iterated or repeated integral. For example, if the double integral R, if you find f of xy into dy into dx, or if you find the double integral f of xy into dx into dy, then f of xy, which is equals to x cube y square. For example, it means if you find the integral with respect to y, then x keeping fixed, after integration we will applying the limits and solve the values if you have given. That's why this type of integral is called iterated or repeated integrals. So now we consider an application of iterated integral. The question is, evaluate the iterated integrals if the integral from 1 to 3, if the integral from 2 to 4, function if you have given 10 minus 3 of xy into dx into dy. For example, first problem, we solve it. It means if you have given the function, it is f of xy. If you integrate with respect to x, then y. What does it mean? It means first we will integrate of the given function with respect to x. So start the solution. If we write here 2 to 4, it is a limit of x into dx. It means y keeping fixed. It means it is the first step, and then we find the function. So it means when we integrate with respect to x, it is 10x minus 3 x dx, it is x square upon 2 of y as it is. And when we put here, applying the limit after integration into dy, and the limit of y is 1 to 3 as it is. When we applying the limit, student, upper and lower, the answer it is 10 minus 4 square, it is 16. 16 divided by 2, 48 upon 2. It is upper limit. Now the lower limit, it is 10 minus 10 of x, 10x. If you integrate, so 10x minus 4, it means 40. Sorry for that. Ten into 4, it means 10 fours are 40. So if we write directly, 10 fours are 40 when we are applying the limit. When we are applying the lower limit, it means 10 into 2 is 20. Minus when we are applying here 2 to the square, the square of 2 is 4. 4 divided by 2, 4 3 is 12, 12 divided by 2 it is 6. And if you solve it, the answer it is 24. So after simplifying, we will integrate the given function of y as it is in both cases. It is 1 to 3. 40 minus 20 is 20. So 20 minus 18y into dy. In the next step, student, we will determine the integral value with respect to y. It means the integral of 20y minus 18y square over 2. The next step, we will put the upper and lower limit and find the answer. 2 9s are 18. So it is 2 into 3 minus 9 into 9. It means the 81. And we are applying the upper limit. Similarly, for the lower limit, it is 20. 20 into 1, it is 20. 1 square, it is 9. So it means minus 9. If we solve it, 60 minus 81 minus 11. So it means 60 minus 92. The answer it is minus 32. Right? So in this way, it means the iterated integral, the first step, it means the first stage when the integral of the given function with respect to x, when y keeping fixed, then we will, after integration of with respect to x, then we integrate with respect to y. The answer it is minus 32. For example, student, if we consider the similar function and evaluate, now the next question is, if we consider the function it is similar, 10 minus 3xy, it is f of xy, but if we integrate with respect to y, then x, and the limit from, if y, the limit of y is in this way, it is 1 to 3, and the limit of x is 2 to 4. So in this problem, student, we will integrate with respect to y first, then x keeping fixed. So we will start from the first part. If we show here in the first step, 10 minus 3xy into dy into dx. It means the limit of y is, we show here, and the limit of x it is 2 to 4. So first we integrate, student, we will integrate with respect to x first. So the integral value is 10y minus x keeping fixed, 3 as it is, and the integral of y dy it is y square over 2. Then we are applying the limit in the next step after integration. If we put here the upper limit in terms of y, 10 3 is 30 minus 3 square it is 9, 9 3 is 27. So 27x upon 2. Then we are applying the upper limit, and the lower limit it is 1. When we put here 1, so 10 minus, when we put here 1, so 3 upon 2. So minus 3 over 2 of x into dx. So if you simplifying them, so 30 minus 10 it is 20, minus 27 and minus 3x it is minus 30 over 30x upon 2, and 30x upon 2 it is 15 into dx. If you simplifying them, it is 15x So 20 minus 15 of x into dx. After simplifying, we will integrate with respect to x. So the integral is 20x minus 15, as it is the integral of x dx, it is x square over 2. When we applying the lower and upper limit, and when we solve it, 20 into 4, it is 80, minus, when we put here the upper limit, 4 square, it is 16, 16 divided by 2, it is 8, and 15 into 8, it is 120. When we applying the upper limit, and when we applying the lower limit, it is 20 into 2, it is 40, minus sign, 2 square, it is 4, 4 divided by 2, it is 2, and 15 to the 30. Simplifying them, 80 minus 20, it is minus 40. In the first term, so minus 40, and minus 40 minus 30, it is 10. So the answer it is, have you any? So student, I have a mistake, some mistake we have. The problem it is minus minus plus, we will miss this value. So it means it is change the value. So we will remove the value. I have a mistake. We miss the negative sign because so student, 30 minus 10, it is 20. We will write here minus 27 minus minus plus 3x. So it means minus 27 plus 3x upon 2. It means minus 24 x upon 2 of dx. In the next step, it is 20 minus 12 of x into dx. Then we will integrate with respect to x. So the integral of x is 20x minus 12 into x square upon 2. Applying the limit in the next step, 20 into 4, it is 80, minus 2, 6 are 12. So when we put here 4, 4 square, it is 16. 16 multiplying by 6, it is 96. Minus sign, when we applying the lower limit, 20 into 2, it is 40. Minus sign, 2 square, it is 4, 4, 6 are 24. So when we simplifying, 80 minus 96, it means it is minus 36, and it is minus 96. I have a mistake. We're applying the limits. 20 into 2, 4, it is 80. 80 minus 4 square, it is 16. 16 multiplying by 6, it is 6x square. For example, if we solve it, then separate and separate them. If you integrate is 20 into x into dx, if you integrate separately, minus 12 of x into dx. If you integrate with respect to x, in both cases 20x, it is 2 to 4 minus, it is easy for you because you have some mistakes. If you integrate directly, so the 20 into 4 minus 2 minus sign 2 divided by 12 means it is 6 x square. It means 16 minus 4. 2 ka square, it is 4. If you solve it, 20 into 2 minus 6 into 12. So it means 40 minus 30, 72. It means the answer it is minus 32. So the student, if you integrate the partial definite integral, iterated integral, if we integrate with respect to x in the first case, and in the first case in iterated integral, when the function it should be similar and the limits are should be similar, it means if you integrate the answer it is with respect to x then y, the answer is minus 32. Minus 32. But if you integrate with respect to y then x, it is the answer it should be minus 32. Both answers are similar. So according to Fubini's theorem, so we applying here according to this application. What is Fubini's theorem? Fubini's theorem says that on if you integrate the double integral r f of xy into dA, which is equals to, if you integrate with respect to x of the given function then y, or if you integrate with respect to y then x, it means the answer it should be similar. So according to problem number 1 and 2, both results are similar. If you integrate with respect to x of the given function then y, and if you integrate with respect to y then x, it means from question number 1 and from question number 2 of iterated repeated integral, Fubini's theorem, and proved according to Fubini's theorem, if you change of order of integration with respect to x then y and with respect to y then x, the answer it should be similar. So both answer it should be similar. So this is called Fubini's theorem. For example, if in double integral student, we will consider the double integral if you find the volume. So use a double integral to find the volume of the solid that is bounded above by the plane when the equation of plane you have given z is equals to 4 minus x minus y, and below by the rectangle and below by the rectangle. The limit of R means the region, rectangular region. The limit of x is 0 to 1 and the limit of y is 0 to 2. Now, student, we will consider the diagram. With the help of diagram, we will find the double integral. Use a double integral to find the volume of the solid that is bounded above by the plane. It is bounded above by the plane. The plane equation you have given, z is equals to 4 minus x minus y. It means the value of z is 4, 0 to 4, and the value of x it is 1, and the value of y it is 2. So we will consider here the limit of x is 0 to 1. If we consider it is x, it means 0 to 1, and 0. The limit of y is 0 to 2. So if you applying the formula, so first we write the formula. How can you find it? The volume of double integral. So volume of double integral, which is equals to double integral R. R is a rectangular region of f of xy into dA. So student, if you consider dy into dx, or if you integrate dx into dy, in both cases the volume of double integral it should be similar. So anyone, if you consider it to solve this problem with the help of this condition or this condition, it should be similar. So now we will consider any one condition. So therefore volume is equals to double integral R. If we consider the function, it is 4 minus x minus y. It is called z because z is equals to f of xy, which is equals to 4 minus x minus y into dy into dx. For example, if we consider in this way and find the volume, the limit of y is 0 to 2. First we write here, and the limit of x is 0 to 1. We write here. Both are the limits of y and x. We denote it as. So first we will integrate with respect to y. 4y minus xy minus y square upon 2, and the limit is 0 to 2 of y. We put here 4y right, into dx, and the limit of x is 0 to 1. So student, if we after integration, we will put here the upper and lower limit. 4 into 2 it is 8 minus 2x minus 2 square it is 4. 4 divided by 2 it is 2 into dx. The integral from 0 to 1, it is the limit of x. 8 minus 2 it is 6. So the answer it is 6 minus 2x into dx. The limit from 0 to 1. In the next step, student, we will integrate with respect to x and find the volume. So 6x minus 2x square upon 2, and the limit of 0 to 1. In the next step, we will applying here. 6 into 1 it is 6 minus 2 divided by 2. When we put here 1 square it is 1. 6 minus 1 it is 5. So the volume of solid it is, hence if you write the answer in this way, hence the volume of the solid 5 cm cube, because the unit of volume is cm cube. So after that, student, we will find the area with the help of double integral. So discuss another problem when we find the double integral, when we find the area in double integral. So that's why in the next. Thank you very much. God bless you. Love.